Hello everyone and welcome back to Post Network Academy. I am Bindeshwar and in today's video we are going to solve a variety of interesting problems related to binomial distribution. So whether you are a student preparing for exams or someone looking to strengthen your statistical skills, this video will walk you through step-by-step solutions with clear explanations. So without further delay, let's get started. So the first question is given, is it possible a binomial distribution has a mean of 3 and variance of 4? So it is given that mean and variance are given. So we know that mean is NP, where P is the probability of success in each trial and N is number of trials. And the variance NPQ, and where Q is 1 minus P. So from the question it is given that NP is equal to 3 and NPQ is 4. So if we divide NPQ by NP, that means if we divide variance by mean, so we will get Q, that is 4 upon 3, and because Q is also probability and it cannot have value greater than 1, so this is not possible because Q being a probability cannot be greater than 1, so it is not possible. Let us see the second question. Find the binomial distribution. We need to find out distribution when sum of mean and variance of 5 trials is 4.8. So number of trials 5 and this is the distribution, and another one is given that here this one NP plus NPQ, that would be 4.8. That means sum of mean and variance of 5 trials is 4.8. Now N is 5, so if we substitute, so we will get 5p, this equation we will get, and Q is 1 minus p, so we will get this equation, and this would be a quadratic equation in P. So again one step ahead, this one if you multiply by 10, so we will get 100p minus 50p square is equal to 48. Now let us divide it by 2, so we will get this one. Not divide, just here rearrange the terms, we have got this one. Now if we solve, again we can reduce, divide it by 2, now we will get this one. If we solve, so we will get P, that would be 4 upon 5 and Q 1 upon 5. There would be two roots, other root rejected because it has value greater than 1, so I have rejected because probability cannot be greater than 1 or less than 0. So the binomial distribution is, we will have 5 already n x, and the P rejects 1 upon 5, where x is 0, 1, 2, 3, 4, 5, 0 to 5. So we will get Px 0, that is 1 upon 3125. The same way we can get. Now let us see another example. The mean of binomial distribution is 30 and the standard deviation is 5. We need to find out N, P and Q. First question. Second question, find out moment coefficient of skewness, and third one kurtosis. So mean is given that 30 and standard deviation, that is square root of variance, that is 5. So we will have NPQ, that is equal to 25. Thereafter we will get Q 5 upon 6 and P, that would be 1 upon 6, and NP, that is 30. So N we will have 180. Now moment coefficient of skewness, so we need to find out actually gamma 1. So that would be Q minus P upon under root NPQ. In previous videos I have explained. Thereafter just plug the values and we will get 2 upon 15. This one would be the answer, 2 upon 15. Now kurtosis formula, 3 plus 1 minus 6 PQ upon NPQ. So plug all these values, we will get 1 upon 50, that is greater than 0. That means it is positive. So that means distribution is leptokurtic. It's negative. Here another question, 7 coins are tossed, the number of hits is recorded here in the table. So what we need to, the experiment is repeated 128 times. The following frequency distribution is obtained in the table. Fit a binomial distribution. Basically the problem is to fit a binomial distribution assuming the coin is unbiased. So coin is unbiased means the probability of getting head is 1 upon 2 and getting tail is also 1 upon 2. So Q. Number of trials 7. Number of experiments 128. So just we have got N 7 and P half and Q half. So the binomial probability we will have this one. Now expected frequency, you know that we will multiply N, capital N, into probability function, binomial probability function. So we will have, you can see that P0 here, 7 P1, 7 upon 128, this one P3, P4, P5, P6, P7, and expected frequencies we will multiply 128 from each. So 1, 7, 21, 35 here expected frequencies. So here that is capital N and that is Px. So that 1, 7, 21, 35, 35, 21, 7 and 1. Now if you see the table, the same thing I have written here. Let us see another problem. Out of 800 families with 4 children each, how many families would you expect to have 3 boys and 1 girl, assuming equal probability of boys and girls? So this probability it is asking. So let us see. Given number of families, that means 800, capital N, number of children small n 4, probability of boy half because equal probability, probability of girl half. Just plug the values. So basically we need the probability of exactly 3 boys and 1 girl. So here we will have 3 n and 1 girl means n minus x. So 4 minus 3. So we will just plug the value and we will get 1 upon 4. So expected number of families. So 1 upon 4 means 800 into 1 upon 4. So that would be 200. That means 200 families will have 3 boys and 1 girl. So hope you understood. For more videos, you can visit website, and also for a post you can visit website. You can visit YouTube channel for more videos, Facebook page. You can also visit LinkedIn page. You can also visit GitHub repositories for the code. So hope you understood. Thanks for